In this video, I'm going to solve one very interesting question, and the statement of the question is as follows. Suppose we wish to use an existing long wall and 100 feet of fence to enclose a rectangular region by using the fence on three sides. What is the maximum possible area that can be obtained for such a rectangular region? So the question is that if we have an existing wall, suppose we have an existing wall, there is an existing wall, and we also have a fence. There is a fence which is 100 feet long. And what we want to do is we want to cover a rectangular region by this information. Here we have a wall and we have a fence of 100 feet. So the fence will be used for three sides of the rectangular region. This is side 1, this is side number 2, and there is another side of this rectangle. So one side we have a wall, and another side, this whole side has a fence of 100 feet, which has to be used for rectangular region. So the question is, we have to find the area which gives you the maximum answer. It means that we have to find the maximum possible area. So this is our question. Okay, let me just rephrase it for you. And when you just take a look at the question, so you can divide your question in two parts. The first part is the information that is given to you. And another part is the question that is required from you from the statement. So I repeat over here, we have a wall and we needed a fence. We already have a fence of length 100 feet, and we have to cover the rectangular region which gives you maximum area. So what we do? How can we start this question? Let me just give you the hint. How can you do it? Since these three values are, the purple one has 100 feet, and these are rectangular. They has been molded into the sides of rectangular portion. So the one side you can call that as, for example, x, whatever the variable you want to name it. For example, I call this y. Since in rectangular region, two sides are equal, this side and this side, these two sides are equal, so the another side is also y. The third thing that we want to name is the another side, which is, we call that as x. So according to the question, the sum of these three sides, x plus y plus y, that is equal to 100 feet. That what is given in this question. You can read the question again. 100 feet of fence to enclose a rectangular region. Very interesting. So after some manipulation, we can write it as 2y is equal to 100 minus x, and y will be equal to 100 minus x by 2. So it means that the two parallel sides have a value of 100 minus x by 2 and 100 minus x by 2 as well. Okay. Now we want to find the area. So it means that we can write area as, area means multiply length, which is x, and with the width, and the width is 100 minus x by 2. That's how you find the area. But the question has not been done over here. We have to find the maximum area. You can see that if this is the area, this is the length x, then the length of the wall is also x. So that's how we get the area over here. So we multiply these together, and you can easily multiply these two numbers, and we get minus 1 by 2 x square plus 50x. That's the equation you get. Now the question is how we can maximize this function. So you need to take a help from calculus. And in calculus, we can say that we know that we can find a value which gives you the maximum answer by using first derivative test or second derivative test. So let me just apply first derivative test. dA by, for example, dA by dx, that will be equal to minus 2x by 2 plus 50, and we have minus x plus 50 over here. By second derivative test, we have d square a by dx square, and we have minus 1, and this is less than or equal to, it is less than 0. So it means that it gives you maximum value when we put that equal to 0. This is the critical point. So x will be equal to minus 50. Put that value into the area function, which depends on which depends on x, and we put x is equal to minus 50. So minus 1 by 2 minus 50 square plus 50 minus 50. I hope there is no error over here. After solving that, which I already did, which I already solved that, and the answer, maybe x is not minus 50, x is 50. I'm sorry. This is 50. So I put 50 over here. So this is 50 and this is 50. Okay. So after multiplying and solving that, we get 1250 square feet as the answer. So the maximum area you can get is 1250 square feet when x is equal to 50. So this length will be 50. This length will be 100 minus 50 divided by 2. So this will be 25. This side is 25 and this side is 25 and so on. If this is 50, so this will also be 50. So that's how you get the maximum area.